Good afternoon, everybody. Mr. Motorhone here, and we are going to do a lecture on triangle area, specifically triangle area for non-right triangles. So I'm going to start off by reviewing what I believe you know about triangles and their area, and then transitioning to this new type of triangle where we're seeing less and less right angles. So I'll start off with this first one. So this is your typical integrated one, maybe even before that, 6th, 7th, 8th grade triangle. Your teacher would put it up and they would say, okay, find the area of the triangle. And pretty much the only formula that they would have you use was area is equal to 1/2 base times height, right? And hopefully you also learned the distinction between the base and the height. So the base is usually the one that is, I guess I don't want to say flat because it depends on the orientation of the triangle, but usually it's the one that's touching the ground, the base of the triangle. And then we also consider the height of the triangle, which for this case, I'll highlight that right there. Okay, so that's usually what we call the height. And one good trick is to always look in between the base and the height, and you should find a right angle, right? So pretty much what that means is this 9, while it is in the image and while it is a property of the triangle, is not something that we consider when we're finding the area. So we would say, okay, area is equal to 1/2 base times height. That would be 1/2 of 48, which would make the area of this triangle 24, and I'm going to put units squared. Okay, so that would be the area of that specific triangle. Okay, now specifically with regard to right triangles, so we know it's a right triangle because we see the obvious little right angle there. And again, we would figure out where is the base, where is the height. So again, base is usually the one either touching the ground or in the orientation that is flat. And then height is usually the one from the lowest point of the triangle to the highest point on the triangle. So we could also find the area of this triangle. We would say area is 1/2 base times height. That would be 1/2 of 60, which would be 30 units squared. Okay, notice I'm being very intentional about the units as well. Whenever we calculate perimeter, area, length, volume, we always want to make sure we're being precise with the units. Okay, now here's the thing. So now we get to a problem like this one, right? Notice that the triangle has information, right? We have side lengths and stuff, but notice in this case we knew a bunch of side lengths, this case we knew a bunch of side lengths, and in this case we are aware of an angle measure right here, 34 degrees, right? So notice that in the other cases we had the height or the altitude of the triangle. So in this case we knew this right here, the height, and in this case we knew the height right there. In this case we have no height, so we can kind of imagine one. Let me get smaller little dots there. So we can kind of imagine a height right there, right? And because we know SOHCAHTOA, we could figure out the height of the triangle. So I'm going to go over here to the side real quick, and I'm going to sketch that triangle that we have. So we know a 34 degree angle, we know 7, and okay, here's the thing. On the bottom, this is part of what down here was 12. So down here, this whole thing was 12, right? But in our triangle, we're only looking at this part. So I actually don't know how much that is. I would love to assume that it is 6, but unfortunately we can't say for sure that this is perfectly halfway through. But I do know that this side for sure is 7. So I'm going to stick with 7. And I know that because this is the right angle, this would be my hypotenuse. So this is hypotenuse. And I want this over here, right? The height of the triangle. Okay, so that would be my opposite. So if I have opposite and hypotenuse, I'm not using adjacent because I don't know the specific length, then OH would give me sine. So I can say sine of 34 is equal to x over 7. I can do a very quick cross multiplication. X is equal to 7 times sine 34. And let me pop that into Desmos real quick on my computer. Desmos.com. And if I do 7 times sine 34, let me make sure my calculator's in degrees, I get 3.91. This is about 3.91 units. Okay, and then I could go about finding the height. I mean the area. So area would be 1/2 base times height. And the calculator will tell me really quick 1/2 base times height. So according to Desmos, the area of this triangle is 23.46 units squared. Okay, so nothing wrong with that. But if you remember when we were doing all of this stuff about the law of sines, the law of cosines, all of our formulas pretty much were based off these pieces. So remember we said all the capital letters represented angles, and all the lowercase all the lowercase letters represented sides of the triangle, right? So I want to see if we can explore how to represent the area of the triangle using only those things. And it's going to be somewhat similar to what we just did, okay? So the first thing I'm going to do is I'm going to treat this down here. I'm going to treat this down here as the base of my triangle. The reason that that is important is because if I turned the triangle another way, so if I went like this, right? If I turn my triangle like that, I could treat A as the base of the triangle, and if I went like this, I could even treat that as the base of my triangle. But for simplicity and because the image is already oriented that way, I'm going to treat this as, and because it's called B, I'm going to treat that as the base of my triangle. Okay. Then we don't see the height per se, but I'm going to draw one. So the height goes from the very, very top all the way down, touches the bottom or the base of the triangle, right? Now notice when I drew that altitude, I also kind of cut through angle B, so I can't really use angle B much anymore in this calculation. Okay, so remember that the area of the triangle overall, right, is 1/2 base times height. Okay, so if I go from this side, so I'm going to treat this triangle. So I'm going to play around with this green triangle for a second and see what we can come up with. Okay, so I'm going to call this H. And in our final answer, remember that H is just a temporary variable, so I can't actually use H in my final answer. So I'm going to use it for now, but I'm going to get rid of it. So far, I have the area of the triangle is equal to 1/2. The base of this triangle is B. I'm going to call it B. And right now, the height of my triangle is pink H. I'm going to put pink H. Okay, so little b is not the problem. Little b I'm allowed to have in my equation because little b was a part of the triangle originally. What I need to be creative about is this h. So I'm going to pull out this green triangle. It looks kind of like this. And what do I know about it? So I know this is little c. I know this is capital A. And I know that this is h. That's pretty much all I know because I cut through B, so I don't lose it. So I could, if I use this as my angle, I could set this up as the hypotenuse, the opposite, and the adjacent, which is useless. So I could set this up as sine capital A is equal to height. Keep in mind that's not hypotenuse, that's height over C. And if I do a little cross multiply, I'll get another way to say height is little c times sine of capital A. Okay, so why is that useful? Well, it's useful because now what used to say little h, and let me make that pink to coordinate. So keep in mind that these pink h's are not different. So keep in mind that this h and this h are the same thing. So according to this green equation, I could do a quick substitution for this h, and instead I could call it all of that, c times sine A. So I'm going to come over here, substitute, and that would mean that another way we could calculate the area would be A is equal to 1/2 little b times c sine A, capital A, right? And ta-da, we have one of the versions of our new area formula. So if we don't know the height of the triangle, we can embed it by using this formula, okay? So again, just like a lot of our formulas, there's a couple different versions. So this is version 1. Area is equal to 1/2, and notice the letters. So this is little b, little c, sine big A, right? Let me color code real quick. Here, I'll do this. So we have little b, little c, sine big A, right? What's another version of the same formula? Well, we could have area is equal to 1/2. Well, what if we don't want little b, little c? Well, what if we want little a, little b? Then what would the angle be? Well, notice we used A, B, C, so I already used A, B, so then the last one would be capital C. And if I wanted the third version, I could do 1/2. Well, I already used BC, AB, so the only combo I'm missing is AC, and then sine of, what's the only letter I didn't use? I used A, C, so then this last one has to be B. Okay, so these are the versions. Let me make this as big as I can. Okay, so these are the versions. Again, please don't try to memorize all 3 versions. Just understand that you need 2 side lengths and 1 angle. And I'm going to show you a really easy way that you can hopefully remember this.